Okay, so let me go to the fragment shader now then. So as I said before, the goal of the fragment shader is to kind of shade the pixels or define what color we're going to put in the pixels. And what pixels are these? So the pixels we are talking about is the pixels that are created inside, in this case, the triangle. So the vertices that we create or that we manipulate here, they're going to be mapped into kind of, imagine a triangle, right? So if you have 3 vertices, what you're gonna get in the fragment shader is this set of pixels inside the triangle. So now we don't have the 3 points anymore. We have an array of pixels that we're gonna decide the color of them. And to keep it simple, I wanna just make a red triangle, right? I don't wanna do anything fancy. I just wanna make all the triangles all to be red. So I'm gonna say gl.fragColor equals to vector4 1 0 0 1. What I'm doing here is I'm, again, similar to the vertex shader, this is our return statement. We need to set this special variable in the GPU called glFragColor, which is the color of that fragment or the color of that set of pixels. In this case, the set of pixels are defined by the triangle we created here. But if you change the set of vertices, the fragment is going to also be different. But this fragment is generated automatically for you in the GPU. So you don't have to do anything to get this fragment. It comes to you by default. And you cannot access it like, oh, I want to get the index I and j of this fragment. You're going to have to change all of them together. So right now, we are saying we want to paint all these pixels red. And the special variable we have to change is this gl_fragColor. And that's it for now. Like, this is our first vertex and fragment shaders. In this course, and like, as I said, and again, what is important is what is valid here in general is also valid here, or the syntax is exactly the same. And there is some differences. In the fragment shader, it doesn't make sense to use attributes because attributes are defined per vertex. And as I said, fragment shader doesn't operate on vertices, it operates on fragments. So there is some differences between the fragment and the vertex shader, but overall, the syntax is the same. The types are the same. You know, you have vertices, you have integers, floats, you have functions. The same syntax you apply for both the shaders. Okay, so we wrote all of this, and nothing's going to change in our application so far, because now that you have these 2 independent programs, we have to compile them and send them to the GPU. Right now, they're just strings. So as any program, we normally have to compile, we have to turn it into some sort of a machine code and send it to the processor, in this case, the GPU. So to do that, we're gonna use a library function. And this comes with the book. And we're gonna do here, actually, let me type it like this. So there's a function called init shaders. And here you give your GL object and your 2 programs. So in this case, vertex shader and fragment shader. So here what we're doing is we're compiling the shaders and kind of like sending them to the GPU. It's actually sending them to the GPU. And let me wrap this with this if statement to say if there's an error, I'm going to say failed to compile and load let's use load here and load shaders. And here we say return -1. Now we have the shaders. If this worked, if we don't get any errors, we should have our shaders ready to be used. But we are not drawing yet. We are just like, we now just have the shaders ready, but there's more to do to draw. So let me refresh the page and see what we get. So there is, see, like here on the console, we get some compilation errors. And these are, they are errors in the shader. So say fail to compile and load shaders. And let's see what I did wrong. Let me see, it's saying medium, because there's a, see, like is medium P. Here I wrote medium, so I just had a typo here. All right, so this was a typo. Let me try to refresh again. And there you go. It's compiled perfectly now. We don't get any errors. And I think we can take a 5-minute break right now, so we can come back at 11:05.